what is an IP address, what is IPv4 and IPv6 protocols. An IP address or Internet Protocol address is a numerical label assigned to every device on a computer network, acting like a digital street address to identify the device and its location, allowing data to be sent and received over the internet or local networks. Let's imagine that as a gigantic worldwide portal system. When you want to send a letter, which is like sending a message or a data on the internet to a friend, you must need a unique street address to make sure that the letter gets to the right house. And IP address, which stands for Internet Protocol Address, is that a unique street address from your device, like your smartphone, computer or tablet. Its function is to tell the other devices where to send information to and where your device send information from. So as Internet Protocol Address is like a unique address or unique code or unique number that is assigned to every device which we use that has an internet access. So it is used to identify the device uniqueness and to identify the receivers or the other devices uniqueness. Also, the protocol, Internet Protocol, is a set of rules like a post office rulebook that determines how the data is packaged and sent using these addresses. We can understand that with an example. When we type youtube.com into the browser, your device or computer, smartphone sends a request. This request has your IP address on it. So the YouTube server knows exactly where to send the video data back into. So if your device has a unique IP address and when you send a request through internet to the site knows that they have to send back you the information through that IP address which they got from your device. If we didn't had IP address, there would be a lot of confusion. IPv4 protocol, or that is Internet Protocol version 4. It is the original version of the address system of IP address. It has long numbers broken into 4 groups separated by dots. For example, you can see it is 192.168.1.1. It is an example. However, the numbers which we are seeing, that is 192, it can be up to 255 and so on and so forth. Like 168 is also mentioned, it can be up to 0 to 255 and so on, 1 point and also 1. So that is the Internet Protocol version 4, and also it was designed a long time ago. It can create about 4.3 billion unique addresses. We can think of it like a town that has 4.3 billion house numbers, but with everyone in the world having multiple devices, phones, tablets or everything, we would be running out of that unique addresses. So example, our house or home uses main public IPv4 address for whole house, like a big apartment building address. Your router then gives each device inside your home a private address, that is 192.168.1.10, that is only used inside your house. That saves the public IPv4 addresses, but it's only a temporary fix. You can understand that to run out of this 4.3 billion unique addresses, which sounds like too much, but it is specific to that 4.3 billion, so it is limited, we can say. So to fix that problem temporarily, we assign that to each house or main home with that one address. It is a temporary fix. To fix it permanently, we had introduced, or Internet Protocol has introduced, the protocol that is IPv6 or Internet Protocol version 6. This is a new and improved version of the address system to solve the address shortage. As in the previous IPv4 protocol, it has limited, although it looks like 4.3 billion is too much, but it is temporary or limited, as to like population might increase, devices can increase. So to fix that issue, this Internet Protocol version 6 was introduced. It has much longer addresses that uses numbers and letters separated by colons. Because it's so long, it often has shorthand rules like skipping groups or zeros. For example, you can see 2001. For example, you can see 2001 colon 0 db8 colon 8583 colon 4 zeros colon 4 zeros colon 8 a2e colon 0370 colon 7334. It is a long address, so it has much more uniqueness, and it can have much more possibilities, which is in the solution address for everything. IPv6 can create a huge number of addresses, that is about 340 trillion, and also that's under like a 340 under zillion. That is a lot. That means every grain on the sand of earth could have its own unique IP address, and we still wouldn't run out. So to fix that limited IPv4 4.3 billion issue, we had created IPv6 protocol that has enough IP addresses that would fill the sand on the earth, and we would be still having a lot to left for to use. It allows every single device to have its own unique address, making the internet simpler, faster in the long run. For example, every device computer in the world needs its own address for the internet. IPv6 adds more than enough numbers to give every single one a complete unique address, no sharing needed. The topic is octet structure in IPv4 and how to convert decimal octet to binary and binary octet to decimal. The calculation of an IPv4 octet is based on binary system and powers of 2. An IPv4 address is 32 bits long and is divided into 4 8-bit sections or octets. You can understand this by thinking we should know first that what is the structure of IPv4. IPv4 is a structure in which it has 4 parts, that is numericals, which is separated by decimals. It is like 192.64.32.8. So it has 3 decimal points in between, separated by each numericals. And each of that numericals can be either from 0 to 255. And each of that is of 8 bits. In total, 8 into 4 equals to 32 bits. So octet structure. Each octet is 8-bit long. In binary, a bit can be either a 0 or a 1. Also, the prerequisite is knowing the computer, device or system level language is binary language, and devices and computers only understand binary language, that is from zeros and ones. And to convert an 8-bit binary number into a decimal, the number you see in an IP address, you multiply each bit by its corresponding power of 2, starting from 2 power 7 on the far left down to 2 power 0 on the far right. The positional values for the 8 bits in an octet are, so you must understand the octet structure in a way, like as I mentioned, it's 8-bit, and as it says octet, it is 8. So it would be the values of that octet are from 2 power 0 to 2 power 7, which makes 8 values. So you must know like bit position, that is from 2 power 7 followed by 2 power 6, 2 power 5, so on until 2 power 0. And its values are mentioned as 2 power 7 is equals to 128, 2 power 6 equals 64, so on until 2 power 0 equals 1. And the minimum value for an octet, all 8 bits are 0. So the minimum value of each octet in an IPv4 is 0, and the maximum it can be is 255. So it is mentioned in an example that is 0 into 128 plus 0 into 64, so on until 0 into 1 all calculated equals to 0. And also for the maximum as well, it would be 1 into 128 plus 1 into 64, so on until 1 into 1, which all added and multiplied equals 255. So that was about the octet structure. Now let's understand how to convert octet binary into the decimal. So we will be taking an example of a binary octet that is as follows, which is 10101100, and we will calculate its decimal value. So the first step would be to mention or map the position value and binary octet. So we must know that position values are always the 2 power 7 until 2 power 0, which we understood in the previous section. So you must mention that 128, 64, 32, so on until 1. And the example octet we took was binary octet 10101100. And now the step 2 would be multiplying each binary digit by its position value. So it would be as simple as 1 into 28 plus 0 into 64, so on until 1 into 1. And the step 3 would be summing all the results. So it would be adding all the calculations of the step 2. So the result would be 172. So that was about binary octet to decimal. Now let's understand how to convert decimal octet into the binary. So for this we have to reverse the process. So let's take an example of an octet value of 192. We will convert it into the binary. For this we have to mention as usual 2 power 7 until 2 power 0 values, which is like 120, 128, 64, so on until 1. And the second section would be calculation side. For the calculation side, you have to mention the first in the first number would be the example that you have taken, or what is the value of the decimal, which in here is 192. The first side would be 192 minus the power of 2 power 7, which we have taken in the previous side by side table. So we mention 192 minus 128, which equals 64. So if the result is calculated or if it can be subtracted, we take the result bit as 1. So on the result section, it is mentioned like, since the subtraction was possible, we take the result bit as 1, and we have got the remainder as 64. And we continue this process by 2 power 6, which equals 64. So we take the remainder which we got from the previous calculation, 64 of the previous calculation minus the 64 of 2 power 6, which gives the result as 0. Since the subtraction was possible, we take that as result bit 1, so which gives us the remainder 0, and so on further. As we got the remainder 0, we take that as a first digit minus the 2 power 5, I believe, which is not possible. So since the remainder is already 0, we take that as 0, and so on until 2 power 1 or 2 power 0, we take that all as 0. So the resulting 8-bit binary octet which we get from the decimal value of 192 would be 11000000. So the topic is, what is subnets or what is subnetworks, what is private or public subnets, CIDR calculations, how to calculate total addresses and usable host from a CIDR number, and how to calculate CIDR number from total addresses and usable hosts. So what is a subnet? Subnet is a network inside a network. Think of it like an organization's network in a large city. Subnets are different neighborhoods within that city. The purpose of subnet is to divide large network into smaller, manageable segments. This offers several benefits such as efficiency, security, IP address management. For efficiency, it makes routing network traffic more efficient as data packets only need to travel within their local subnet before they are routed to a different one. For security, you can apply specific security rules to a different subnet, isolating certain devices or services. It helps conserve and organize the available IP addresses. The purpose of subnet is to provide more efficiency, security, and to isolate the services that are offered to members. In an organization that has leaders, interns, managers, team leads, so the importance of subnets increases as certain confidential members should or must be accessing a subnet that is not accessible by other members. So the subnets are a network inside a network, and the leaders or confidential members access the subnet for more security and efficiency. How it works: an IP address like 192.168.1.10 is split into two parts, that is, a network portion and a host portion. The subnet mask or CIDR notation tells devices where the split is. All devices in the same subnet must have the same network portion. So now what is private versus public subnets? The distinction usually comes up when using cloud platforms or cloud environments like AWS VPCs or virtual private clouds. But it is all actually based out of internet accessibility. The feature is internet access. For public subnet, direct internet route via an internet gateway. For private subnet, there is no direct route to the internet gateway. So it doesn't have internet access unless we use NAT gateway for public internet. For accessibility, in public subnet, resources in a public subnet can be reached from a public internet. That would be a web server. For private subnet, resources are not accessible from the public internet. So, example, it would be like a database server. Outbound internet for updates or downloads. For public subnet, it is a direct access. For private subnet, it needs a NAT gateway to access the public internet. Typical resources in a public subnet would be web servers, load balancer, Bastion hosts. In private subnet, it would be database servers, application servers, internal tools. For the simple analogy, it would be like public subnet. It's like a front door. People from the internet can walk up and ring the bell to communicate with services you want. For private subnet, it is like a secured living room. Only the traffic you explicitly allow from the public subnet, the front door, can reach it. Now let's understand CIDR calculations. CIDR stands for classless interdomain routing. It is a standard way to specify the size of a network or a subnet. A CIDR address is written as an IP address followed by a slash or a slash and a number. Example, it would be 192.168.1.0/24. The slash number slash n, this number n is the network prefix length. It tells you how many bits out of 32 total bits in an IPv4 addresses are used for network portion. The remaining bits are used for host portion. You must be knowing that IPv4 has a total length of 32 bits. Network prefix length slash n says how much length has already been utilized by the IP address. So it would be like if it is mentioned /24, it means that 192.168.1, it means that 24 bits already been utilized and the remaining bits are 8 that are yet to be utilized. So for the remaining 8 bits, it can be made a subnet. So the rule would be the number of available IP addresses is calculated using the formula 2 power h, where h is the number of host bits. What are the calculation steps? First would be find the host bits. Subtract the CIDR number n from the 32 of the total bits in an IPv4 address, which would be h equals 32 minus n. 32 is the total length minus n. Second would be find total addresses, which is calculating 2 power h, which is like the usual calculation of 2 power. Third would be finding usable addresses. To subtract 2 from the total, as the first address network ID and the last address broadcast address are reserved. 2 addresses are already reserved, that is for network ID and broadcast address. So it would be usable host 2 power h minus 2. Total addresses are 2 power h. For the usable one, it would be minus 2 of that. So the CIDR, the table shows the CIDR slash n, which we already know would be, if it is slash 24, so it would be host bits, that would be h equals 32 minus 8. So 8 would be 2 power h. H is from what we got from the host bits, 2 power 8, which equals 256. So total addresses is 256, and minus 2 of that would be usable host, which is 254, and so on for other CIDR notations as well. The thing to note is that the smaller the CIDR number, example slash 16, the more host bits you have and the larger the subnet. The larger the CIDR number, example slash 30, the fewer host bits you have and the smaller the subnet. So now let's calculate CIDR number slash n when we know how many hosts or how many total addresses we need. To find CIDR prefix slash n, we need to do the calculation backwards, which would be account for the reserved addresses. In every subnet, 2 addresses are reserved, which you already know, that is like network ID and the broadcast address. The formula would be total addresses equals usable hosts plus 2. For example, it would be, if we need 50 usable hosts, we need a block of 52 addresses. The second step would be next power of 2. IP addresses always comes in blocks. We must know that it is the power of 2. It would be like 2, 4, 8, 16, 32, 64, 128, so on. You must find the smallest power of 2 that can fit your total addresses. From our previous example of 52 addresses, the next power of 2 is 64. Since 2 power 6 equals 64, your host bit is 6. Step 3 would be subtracting from 32. Since IPv4 address has total bits of 32 bits, just subtract your host bit h from 32 to find your network prefix n. So the formula would be n equals to 32 minus h. Calculation would be 32 minus 6, which equals 26. So the result would be slash 26 subnet. So here is the table that shows how to calculate that. So first it is usable host needed, total addresses, host bits, CIDR result. If usable hosts needed are from 1 to 2, 3 to 6, 7 to 14, so on until 127 to 254, we take the total addresses 2 power h, that is 4, 8, 16, 32, 64, 128, 256. So usable host needed table signifies or simplifies that if the range of the host you need is from 1 and 2, so we take that as 4. 4 it would be as 2 of the 1 out of 2, and plus 2 total host you need or usable host you need are between 63 to 126. Anything between that, we take the next power of 2. It is 63, 65, 70, 80. The next power of nearest would be 128, higher than that. So we take that as in the total addresses. So on, like if the range is from 127 until 254, anything between that numbers, we take the next 2 power of 2, which is like 256. so on. Like if it is 7 to 14, if any usable host we need are from between those, so we take the next power of 2, that is like 16. So it would be 2 power 8 equals 256, 2 power 7 equals 128, 2 power 6 equals 64. The power of 2 that gives total address, we take the power as host bits. For the CIDR result, it would be total bits minus the host bit. If the usable hosts needed are between 127 to 254, we take total addresses simply as 256, which is as the power of 2 power 8. So we know that 2 power 8 equals 256. So we take that 8 of that power and we subtract 32 minus 8, which gives slash 24. So we got the CIDR result as 24, and so on. Like for other ranges between 63 to 126, we take the nearest further value of 2 power h, which is like 128, which is 2 power 7. The power of 2 is 7, so we subtract 7 minus 32, which gives slash 25. So it would be some range 192.64.0 point slash 24. So it would give the range something like 192.168.0 slash 24. Also, the pro tip would be, if your number of hosts is exactly a power of 2, like if you are taking hosts that is exactly 64, you must be still adding 2 and move the next power, that is 128, because you can't fit 64 usable hosts in a 64 address block because of those 2 reserved slots. So you know that we have 2 reserved slots. So if we are taking exactly 64 to fit in, you must still have to move that further to the 2 power 7, that is 128. So the topic is, what is DNS resolution and what is authoritative DNS server, what are ports, what is a TCP handshake, how do these work together. So first let's understand what is DNS resolution. A DNS is domain name service. Computers communicate using IP addresses such as 192.0.2.1, but humans use domain names example.com. DNS is a system that bridges this gap. So IP address is what the computers or devices understand. For us, we use the domain name that is like google.com, but computers only understand the IP addresses to fetch the domain you are looking for. So the process is, when you enter a URL, your computer queries a DNS resolver. A DNS resolver finds the authoritative source through a step-by-step hierarchical lookup. It starts with a root server for hints, which directs it to a TLD, or that is top level domain server, that is like .com or .org for the correct zone, and that server that then points to the domain specific authoritative name server, which holds the definitive IP address, returning it up the chain to the user's browser. DNS resolver does these steps. First step is when the user sends the request, that is user request. You type www.example.com or google.com, any website, into your browser. Your computer, your device or DNS client first checks its own cache, and if it is not found in the cached, then it goes to the recursive resolver or DNS resolver. And the next step would be query root servers. Then the resolver or DNS resolver or ISPs ask root name server, example that is for .com or .org, for help. Then it is from the root to the TLD. The root server doesn't know the IP but knows who manages .com. It sends back a referral to the .com TLD server. That means that root server in itself doesn't have the information to fetch the data. Then that root server queries that to the TLD server. Then the TLD servers knows the authoritative name servers for the example.com. Example, it is Google's name servers and refers the resolver to them. So the step that is TLD to authoritative means that the root TLD server doesn't have exact information. Authoritative server is the actual place where your domain name service is located. So these steps from the root to TLD server, that all works to get or refer your query to the authoritative server. So after getting that information or query from those TLD root servers to the authoritative, that authoritative server provides the actual domain name service it has. Example, there is Google's name servers that has all the database. So let's understand that deeply. An authoritative DNS server holds the definitive official records like IP addresses, mail servers for specific domain, acting as the ultimate source of truth for that domain's information, providing final answers to DNS queries for recursive resolvers. Unlike recursive servers that cache answers, authoritative servers contain the original zone files, ensuring accuracy and reliability for translating domain names. Example, google.com into machine readable IP addresses. Example, 142.250.189.110. So this authoritative DNS server actually has exact official records for every information like IP addresses, mail servers for our specific domains. It acts like an ultimate source of truth. If all the information like root server or TLD doesn't have accuracy, so it asks the final truth to the authoritative DNS server for exact information. It refers the query. It is like when we have some certain issues for our products that we order, we does a customer service call, and if the customer service doesn't have the issue that is in his power to solve, they forward that to the higher authority for solving. So it is similar to that. TLD, root, all cache doesn't have exact much more power or exact information, or it is not ultimate truth for DNS resolution. So it has to get towards authoritative DNS server, that for example it is Google's name servers, so they can provide the exact information, that is IP addresses, mail servers for a specific domain. Authoritative DNS servers uh, contain original zone files, original details that provides accuracy, reliability for providing exact details that redirects from example that is google.com into a machine readable IP addresses, that is 142.250.189.110. So let's now understand what are the key functions and characteristics of authoritative DNS server. Source of truth stores the actual current DNS records A, MX, CNAME, etc. for a domain. Official records provides the final correct answer for a domain's IP addresses when asked by a recursive DNS server. Domain specific manages records for specific zones, often delegated from tldservers.com/org. Primary and secondary can have master primary and slave secondary servers for redundancy, both authoritative for the zone. Managed by you. You typically configure these servers through your domain registrar or a DNS hosting provider. So, source of truth, official records, domain specific, primary and secondary is what I have explained. What does managed by you mean? Managed by you means you actually, when you make a website, you have to configure these details like domain name service, which is actually like some examples are like GoDaddy and Google name servers. These are actually the source where DNS IP addresses for your websites are provided. So in that websites, when you create it, you have to provide like what domain name you want to choose and what would be its IP address. So it is a record on that site. We does all this process from TLD root to actually get information through for that site accurately. How it fits in the DNS process. Users type a domain name that is example.com. A recursive resolver like your ISPs, internet service providers, server receives the request. If not cached, the resolver asks high level servers root TLD for directions. Eventually, the request reaches the authoritative DNS server for example.com site. The authoritative server provides the IP address. The resolver catches it for a set time and sends the IP to the user's browser. The result would be the DNS server returns the IP address associated with that name. Context. Without DNS, you would have to memorize a string of numbers for every website you visit. So what does context mean? If there was not a concept of DNS, you would have to, instead of doing google.com, you would have to put actual IP address to get into that site. You would be doing something like 192.128.8.2 and enter. Then you have to go to that site and you would have to remember this to enter other sites as well. For example, if some other sites have some other IP address, you would have to put that to get into the site. The DNS solves that issue by letting you know that you only put what you remember, like google.com, and it does all this backend which I explained to get you to the site. Now that we understood DNS and what is authoritative server, now let's understand what is ports. A single server with one IP address can run many different services at once, like a website, a database, and an email server. Ports are numerical identifiers that ensures data reaches the correct application on that server. And to let the user land on exact, we, instead of putting 192.6.8, we actually add /443. For example, the range of ports are numbered from 0 to 65535. So the ports can be from 0 to 65535. Common standards are port 443 for secure web traffic HTTPS, port 80 for standard web traffic HTTP, port 22 that is for secure remote access SSH. The logic behind the ports. If the IP address is the street address of a building, the port is the room number that tells you exactly which office or which room to enter. Now let's understand what is a TCP handshake. Once your computer knows the IP and the port, it doesn't just send data immediately. It uses TCP, Transmission Control Protocol, to perform a three-way handshake. This ensures both the sender and receiver are ready and can track the data packets accurately. Only knowing IP and port doesn't mean you would directly land to the page. There must be a secure connection between the receiver and the sender, which is known as TCP handshake or three-way handshake. The handshake consists of three specific signals. that is SYN, synchronize. The client sends a request to start a session. Second is SYN, ACK, synchronize, acknowledge. The server replies confirming it received the request and is ready. Third is acknowledge, ACK. The client sends a final confirmation that the connection is now active. TCP handshake means that to send the data accurately and to not have a data loss or packet loss, there must be a secure connection between the sender and the receiver. So it ensures that there is a secure connection to send the data. It means that it asks the client request to start a session, and when both the parties or the server replies and confirms that they are ready to receive and the request, so the client sends a final confirmation that the connection is active to send the request. So what does this full sequence or all these three steps complement each other? So this means that first you type example.com and DNS tells the computer that the IP is 93.184.2.216434. It is an IP address. Then port, your browser targets port 443 at that IP to request a secure web page. That means that 93.184.216.34 is not exactly your website or your landing page. Your landing page is exactly at port 443. It would be something like 93.184.216.34/443 to enter the your web page. So the third step would be like it doesn't directly do that. It must have a secure connection between the sender and the receiver, and there must be synchronization, acknowledgement to perform a TCP handshake. Then that process is complete. So your computer and server performs synchronize acknowledgement and acknowledgement sequence to shake hands. Then the step 4 would be data flow. The connection is now open and the website content begins to load. So today's topic is OSI models or layers of OSI model explained, summary of table of layers in an OSI model. So first understand what is an OSI. OSI stands for Open Systems Interconnection Model, and you can understand this by thinking of it as a 7-story building. To send a message from your computer to your friends, the data has to travel down from the 7th floor to your building, across the street, and end up to the 7th floor of their building. What is the software layers, or that is system or browser level layers? These are layer 7, layer 6 and layer 5 that are system or browser level layers. So these layers happen inside your computer's operating system and applications like Chrome or Spotify or any other browser based or any applications. It is called application layer, that is the interface. What it is, this is what you actually see. When you type google.com into your browser, you are using layer 7 protocols like HTTP or HTTPS. In simple terms, the window you interact with. So layer 7 is the interface or the UI you see in the browser, which is an interactive browser. So application layer is the interface where users can interact. So the layer 6 is the presentation layer, that is the translator. What it is? This layer translates data into form the application can understand. This layer translates data into a form the application can understand. It handles encryption, making it unreadable to hackers, and compression. In simple terms, ensuring the data is in a format you can read. Example, turning bits into JPEG or an encryption SSL message. So this means that in presentation layer, encryption happens. there is a concept of cryptography. Cryptography means the data which you see as a message. If you were meant to send a message to someone on WhatsApp, if you say hello, and that message, when it reaches the user you are sending to, it goes through the process of cryptography to ensure that the data is not seen by the hackers. When you send hello, it goes through a cryptographic so the message gets somewhat like it is not understandable for users or humans. Then that message is decrypted on the receiver's. So this is what the similar thing happens in the presentation layer. So the layer 5 is a session layer, or that is conversation. What it is, this layer opens, manages, and closes the conversation between two devices. It uses cookies to remember who you are so you don't have to log in every time you click a new page. In simple terms, the handshake that keeps the connection alive while you chat. So the session layer simply means that whenever you log into your social media handles, it is always that when you close that app and you open that app again, you don't have to log in again. It is because your session is being started. You can simply do an example by yourself. You can try logging in with your social media handles on your browser and check for the cookies. So when you log in, the cookies are generated or the cache is generated in your browser. So you don't have to do login again and again. So when you delete that cookies, you also delete that session. So the session gets deleted when you delete the cookies or cache. So you have to log in again. So now there is a layer 4 that is known as the heart of the model. That is a transport layer. What it is, this layer decides how to send the data. It uses TCP slower but checks for errors, or UDP fast like video streaming but doesn't care if a few bits drop. In simple terms, breaking the data into small segments and making sure they arrive in the right order. The data is in the form of segments to make sure they arrive in the right order. It uses transmission control protocol and user datagram protocol for streaming the data or sending the data. So now the hardware and routing layers. This is layer 3, layer 2 and layer 1. These layers move the data across the physical world, cables, routers and switches. So the layer 3 means network, the GPS. What it is, this is where IP addresses live. Routers use this layer to find the best path for your data to travel across the internet. In simple terms, addressing the package with a destination IP so it knows which city to go. Layer 2 is data link layer, the local map. What it is, this handles communication between two devices on the same local network. It uses MAC addresses, the permanent ID of your hardware. Simple terms, moving the package from your laptop to your home router. Layer 1, that is physical layer, the cables. What it is, this is an actual physical hardware. This includes Ethernet cables, fiber optics and even Wi-Fi radio waves. In simple terms, the cables and electricity that turns your data into zeros and ones. So what does these hardware and routing layers and heart of the transport layer and that is software layer mean? From layer 1 to 7, layer 1 is from the cables. It starts from the hardware, or that is like cables, fiber optics to transfer your data, which then is converted into the zeros and ones that happens in the physical layer. In the layer 2, that is data link layer, it moves the packages from your laptop or your device, the data, and it converts and uses MAC addresses for each data fragmentation. It adds MAC addresses, so the transfer of the layer must be secure and it must be clean. For the layer 3, in the layer 3, it is where the IP addresses live. Routers use this layer to find the best path for data to travel across the internet. After your data that is traveled from physical layer, that is cables, then it is assigned by MAC addresses. So now it is having some volume to your data. Then the data is assigned the IP addresses to travel to the destination. Now in the layer 3, it knows where IP addresses live and knows the best path or the easiest path or the quickest path to travel the data. Then the layer 4 concept comes. It is when that data, making sure they travel in the right order using the protocols. Sometimes they use TCP or sometimes UDP protocols. So after the data is assigned the protocols for secure travel, then there is the concept that is for the software layers or browser level layers. Then it is assigned the session presentation layer when encryption and session happens, and then the application layer where you actually see the interface of the data that traveled across the cables and all the layers in between that. So the table shows like layer 7 to 1 and its names, that is application layer, presentation layer, so on until physical layer. So unit shows the data from presentation to application to session, and in transport it is segments. The data is converted into segments, and in network layer the data is converted into packets, and in data link it is frames, and in physical it's bits. So as I mentioned in the previous section, that the data, if it is to be traveled from physical aspect to the browser, it uses, like in the physical layer it has bits, and then for the data link it is converted to frames, and in network layer that data is converted into packets and then segments, and so on. It is data until the application layer. And what is the responsibility of these layers? So the first layer, that is physical layer, it is cables and electricity, and for data link it is MAC addresses, and for network layer it is IP routing, and for transport layer reliability, transfer of the protocols like TCP or UDP protocols, and for session layer it is for managing the connection between the layers, between the data and the user. That means if the session is active, there is a connection, and if the session is cleared or the cookies are cleared, the session is ended and it must start with a new session or the login. So then comes the concept of presentation layer and its responsibility, which is encryption and format, and the 7 layer would be application, which means user interface or what you see in the screen or the browser. So if you understand that with a simple analogy, it would be the road, the truck moving the mail, the address on the envelope, the postman, the phone call, the language used, the letter itself. Also, the pro tip to understanding these layers would be, you can understand from 7 to 1 layers using the phrase all people seem to need data processing. So today's topic is, what is VPC, virtual private cloud? What are key aspects of VPC? What are key components of VPC explained? How does VPC work? Comparing security group versus NACL. Watch this video completely to have better understanding of this topic. Think of VPC as your own private, fenced off section of massive public cloud like AWS, etc. So VPC is like a personalized land of yours which you buy from an AWS. If AWS is a world, VPCs are a land you buy to build your infrastructure or cloud. What are key aspects of VPC? Isolation, control, security, scalability, hybrid or disaster recovery. VPCs creates a private segment network within the public cloud, keeping your resources separate from other tenants. As the name says, virtual private. Private means you have your own isolation of your private cloud, where other users will not be able to access your public cloud. Control. You define and control your own IP address ranges, subnets, route tables, and network gateways. VPCs provides infrastructure and lets the users control their own IP addresses, subnets, and route tables and network gateways. It gives users fine-grained access and fine-grained control over their own infrastructure, giving them rules, security for them to decide how much and which traffic is allowed to enter their VPCs. Security enables fine-grained access and controls the security policies, providing a secure space for sensitive workloads. VPCs provide several NACL policies as well as security groups to give you security, and also AWS has its own security as on-premise infrastructure, data center security. Scalability leverages the public cloud ability to scale resources on demand. So it lets users scale their own public cloud. Disaster recovery or hybrid. It can be used to replicate on-premise infrastructure for redundancy and supporting business continuity. AWS provides the data center and the security of on-premise infrastructure. It means that you don't have to manage your own data center and its security. AWS takes care of that. The analogy would be your own private city. If you imagine public cloud is a giant empty continent, when you create a VPC, you are claiming a specific plot of land and building your own private city. You decide who can enter, where the roads go, and which neighborhoods are private. What are key components of VPC? VPC is like a city limits. What it does, the overall boundary and private network space. Subnets are like neighborhoods, smaller sections of your own network used to group similar things together. IP range or CIDR notations are like street addresses, the ranges of numbers or addresses available to assign to your house's servers. Internet gateway is like the main highway, the front door that connects your city to the rest of the world, the internet. Route tables, these are like the GPS or road signs, a set of rules that tells data which road to take to get to its destination. Security group, these are like the personal bodyguard, a firewall that sits right at the door of your server to check who can enter. NACL, these are like the border checkpoint, a firewall that sits at the entrance of a whole neighborhood or a subnet. So now how does a VPC work? When someone from the internet tries to access a website hosted on a VPC, the traffic follows a specific path. The entrance, the request arrives at the internet gateway, which is like the front door. Second, the map. The route table looks at the request and says, you are looking for the web server, take the road to the public subnet. The perimeter check. Before entering that neighborhood subnet, the NACL checks if the visitor's IP address is on the allowed list. If it is not on the allowed list, then the access is denied. The final guard, once inside the neighborhood, the security group, the bodyguard, standing at the server door, does one final check to see if the visitor is allowed to talk to that specific server. If the user is not allowed or is denied, then the access is also denied. The response, the server sends the data back because security groups are stateful. They remember who they let in. The bodyguard automatically lets the response out without checking again. In my previous videos in the playlist, I have already explained what would be subnets and IP CIDR range. You can watch those videos to have the understanding of those concepts. However, in this video, as I haven't explained internet gateway, route table, security group, NACL, I will do that. Internet gateway. The internet gateway is like the front door of your VPC. Without it, your city or your VPC is completely cut off from the rest of the world. It provides a target in your VPC route tables for internet routable traffic. It performs NAT for instances, allowing them to communicate with the internet using a public IP address. One VPC can have only one internet gateway. Route table. A route table is a set of rules called routes that tells data packets where to go. Every subnet in the VPC needs a map or a route to know how to reach other neighborhoods or the highway. When a packet leaves a server, the route table looks at the destination IP. If the destination is 0.0.0/0, the whole internet, the road sign points it towards the internet gateway. Local route. Every VPC has a local route that allows the subnets to talk to each other by default. Public versus private. A subnet becomes public simply by adding a route to the internet gateway in its route table. NACL or Network Access Control List. NACL is the first line of defense or a firewall. It sits at the boundary of a subnet. It checks everyone entering or leaving the entire area. It is stateless. It means if they let someone in, NACL forgets them immediately. You must also have a rule to let them out. Numbered rules. It processes rules in order such as Rule 100 or Rule 200. As soon as it finds a match, it stops looking. Allow and deny. Unlike security groups, you can specifically deny a specific IP address. Security groups. A security group acts like a firewall for your instance. The specific house server. It is the most granular level of security. If you allow guests in, the bodyguard or the security group remembers them. They are automatically allowed to leave without you writing a separate exit rule. Allow only. You can only create allow rules. If there isn't a rule for a specific type of traffic, it is denied by default. Instance level. You can have bodyguards or security groups for different houses even if they are in the same neighborhood. Comparison between security groups and NACL. Security groups protects individual servers or instances. NACL protects entire neighborhood or subnets. Groups are stateful. It remembers incoming traffic. NACLs are stateless. It needs a separate out rules. Security group supports allow rules only. NACL supports allow and deny rules. Security group evaluates all rules before deciding. NACL evaluates rules in numerical order. VPC. So to conclude, VPC is like a city and it has a main entrance that is internet gateway that gives an access to the public or the users all over the world to enter your city, and to reach each houses located in the city there must be a route table or routes, and each house has its own security. So there exists NACL that acts as an entrance for subnet, and security group acts as a personal bodyguard. Security group acts like a firewall for the instance. Hello guys, welcome to this video. Today we are going to be doing the practical session in which we will create a VPC, we will create an instance and attach that VPC to it. Also we would be implementing security manager, attaching NACL policies as well. Logging into your AWS console, then you search for the VPC in it, just as I did. Click on VPCs. Click on Create VPC. That subnets, it shows 4 subnets within this VPC. That is, I am on the region that is Asia Pacific Mumbai, so it says AP South 1A and AP South 1B. In that we have public and private subnet totally. Now name your VPC. I am naming it KF Demo VPC. In the below there is the IPv4 CIDR block. In that previous sessions we discussed how you can create the CIDR notations of IPv4. If it is mentioned 10.0.0.0/16, if it is /16, it has 65,536 IP addresses. So we will not change the default settings, so we'll go with this one. We will also not change the availability zones and all these details. We'll keep it as default and then create the VPC. Now as you can see, it shows in the detail section, it created a VPC, it enabled the DNS host names, etc. All these details related to the VPC. Now click on view VPC. Now you can see your VPC. Now when you see the resource map of your VPC, you can see that in the network connections, it has internet gateway. Now after creating the VPC, let's create an EC2 instance. Click on launch an instance. I'll name it KF demo instance. Let's choose Ubuntu. I'm on the free tier. You can also try it on the T2 micro free tier. Just go below and I'll create a new key pair login. That would be .pem file for a secure shell or SSH login. It's downloaded. Create security group and change the VPC from the default to the VPC which we have created, that was KF demo VPC. So let's select that. Now we have attached the VPC to the EC2 instance. Usually what we do is we select the private subnet of your selected VPC. But for this demo, we would be selecting the public VPC subnet. Click on Auto Assign Public IP enabled. Now let's create an instance or launch an instance. It's launching and it's successfully created. Now copy the public IPv4 address so we can do the secure shell SSH. Git bash as a terminal. You can use others as well to connect to your instance through SSH. Now click enter. Click yes. Enter yes. Now it's connected to SSH or to your instance through your terminal. So apt update. It will take a while to update the packages. Let's wait. Now we'll use Python to host simple http.server on port 8000 to see we can apply security manager and NACL rules to learn them. Enter python 3 m http.server 8000. Click enter. Now it says that the server is serving on HTTP port 8000. When we search our port, it would not open. We can see that the instance is running. Go to the security section in your instance and check for the inbound rules. Since it only allows traffic from port 22 range, that is the range of your SSH connection, you would not be able to access that port. Now let's check the network ACL policies. Go to the VPCs and then go to the network ACLs. Find your subnet, find the VPC which we have connected. Check for the inbound rules of the NACL. We can observe that there is a rule 100 with all traffic that says the source 0.0.0/0, which is allowed. That means the traffic is allowed from the internet. But since the instance security group does not allow traffic from port 8000, it is not allowing us to access that port. Go to your instance, go to the security groups, then change or edit the inbound rules, and we will add another rule that is to accept from the port 8000. So let's create that. Save rule. Now it's created. When we go to that same port which we have created, it would be now accessible since we allowed the traffic from the port 8000. Our terminal also confirms that it says 200, which means it is working. Now as you can observe the inbound rules, the first inbound rule was default, that was to only access the SSH type, which was port 22. Now we have created another rule with the port we have assigned while creating an instance, which was the port 8000. Now that we have created that inbound rule, the traffic is now accessible. So now we can access that port or our link or the site. Now let's try to change some network ACL rules so we can see if we can change the traffic or we can change the accessibility of that port. So let's click on network ACLs in the VPCs and edit the inbound rules. Now by default it says allow. Let's create another new rule with rule number 100. We would keep it at custom TCP with the port range 8000 which we have created while the instance, and click deny. It is updated. Now when we try to access that port again, it would not allow us to refresh or access them as we have denied the port through NACL. Also, the thing to note is that network ACLs or NACLs operate on the subnet level and security groups operate on instance level. So we changed the instance policies for net security groups and we changed the security policies on NACLs for subnets. To avoid manually changing the policies on the security groups by specifying inbound rules 8000, deny or allow, we can use the policies on the network ACLs to do it once. So whenever we attach that VPC, that port range would be allowed or not allowed. We can create multiple NACL inbound or outbound rules in accordance to the traffic which we want to allow or not allow. So if we were to do on the instance level by security groups, we would have to do it again and again after each instance we create. But when we do the network ACL or NACL policies or inbound rules or outbound rules, we have to create, it operates on the VPC level. So it is like we are assigning the EC2 instance the VPC. So VPC, if it has the policies or the traffic rules which you want, we just need to attach that VPC to the EC2 instance. So it's like saving so much of the time. But if not, we would have to do it again on the instance level. If not, we are doing on the VPC. I hope I make sense. Also, NACLs works on sequential order. If the rule number is 100, it works in the sequence like 100, 200 and then star. So when we create a policies or inbound rules, it works with the rule number. We created another inbound rule with rule number 200, denying the traffic for the port 8000. Now that rule will not be effective as the sequence order of that rule is second. Yes, allow, so it allows the traffic. Now let's update the rule numbers so it is in the different order. So let's 200 and 110 save changes, and now the first rule number, that is 110, has the deny for the port 8000, and the second rule, that is 200, has the rule allow on the port 8000. So it would not allow accessing on that port. So that was the video for today, explaining you practically how NACL and security groups work. We have seen in this video that NACLs work on the subnet level, whereas security groups work on the instance level. And we applied different rules according to our port 8000. Thanks. The topic is, what is a load balancer, what is a target group, what are auto-scaling group, and what is an Bastion host in cloud or DevOps. Watch this video completely so you can have better understanding of this concept. So let's begin. What is a load balancer? A load balancer is a device or a software that acts as a traffic cop, distributing incoming traffic network and application requests across multiple servers to prevent any single server from being overwhelmed, ensuring high availability, reliability, and optimal resource use for websites and applications. It sits in front of the servers, performs health checks to route traffic away from unhealthy ones, and can be hardware, software, or cloud-based. Load balancer is like a traffic cop. You can imagine a busy restaurant with a line out the door. The load balancer is the host standing at front. Instead of everyone rushing one table, the host directs each group to an empty seat so that no single waiter gets overwhelmed. So this means like load balancer balances the load. So it balances the load that is to be received on the servers. So it doesn't let single server get overwhelmed with the traffic. So it balances it equally so that the performance is optimal and the system doesn't get overwhelmed. It takes incoming traffic and distributes it across multiple servers. It prevents any one server from crashing due to much work. If a server gets too much of a traffic which it can't handle, the server can break. So prevent that, load balances the load by taking the excess load from that server and transfers it to the idle server. So it is balanced and the performance is ideal and optimal. A target group is a logical collection of resources like servers, IP addresses, functions that a load balancers send traffic to, or a segment of users or customers defined by shared attributes like location, interest for delivering specific content or features, especially defining who or what gets targeted for request or marketing. These groups act as the bridge routing incoming requests or content to the correct backend targets or user segments based on defined rules and health checks, ensuring efficient distribution and personalized experiences. So, the target group is a group or the recipient that the load balancers send the traffic to. As I mentioned before, for the load balancer, the target group is essentially the list of servers that the load balancer is allowed to talk to. Using our restaurant analogy, it is like specific section in the dining room. What it does, it tells the load balancer exactly which servers are ready to receive the traffic. Why it is used, it allows you to group servers together based on their job. Example, one group for the website and another for the mobile app. An auto-scaling group ASG is a collection of compute instances like virtual machines that automatically adjust the size, adds or remove instances to match demand, ensuring high availability, performance and cost efficiency by scaling compute capacity up during traffic spikes and down during lulls based on defined metrics like CPU usage or schedules. G or auto scaling group is a collection of compute instances like virtual machines that automatically adjust its size, adds or remove instances based on the traffic it is received. So it is like a shift manager. The auto scaling group is like a manager who watches how busy the restaurant is. If the traffic cop, that is a load balancer, report that the all tables are full, the ASG or auto scaling group hires more servers. When things goes down, things are quiet, it lets them go to save your money. So what it does, it automatically adds or removes servers based on how much traffic you have. Why it is used, it ensures your website doesn't crash during a big sale and ensures you don't pay extra for servers when no one is visiting. So now what is a Bastion host? A Bastion host or a jump server is a hardened special purpose server in a public network segment like a DM set that acts as the only secure gateway for administrators to access private internal cloud resources like databases or app servers from the internet, minimizing the attack surface by centralized access control and logging for sensitive systems. So Bastion host is like a secure server that the administrator that operate secure server that is used by administrators to access private internal cloud resources like databases. It is like a secure employee entrance. For security, most of your servers are locked in a private room with no direct doors to the outside world. If a technician or administrator needs to go and fix something, they must first go through a Bastion host. What it does? It is a single, highly secure server that acts as a gateway for administrators to log into their private servers. Why it is used? It keeps your main servers hidden from hackers while still letting your team get into their jobs. So it keeps your main server hidden from the public so the only administrators can have access to fix some. So Bastion hosts act as a server that the administrators use to access the backend to fix the errors in the cloud or the server or to access internal databases extra. So the load balancer distributes traffic and it prevents overload. And target group is like a list of destinations that organizes your servers. Auto scaling group adds or removes servers, saves your money and handles spikes. Bastion host is a secure jump point, keeps your server safe. So that was a video today explaining you load balancer, target group, auto scaling group and Bastion host. Hello everyone. Today we are going to be doing the second project on our networking in DevOps series. First, understand the architecture. In this project, we will be creating two private subnets in a VPC, which would be in two different availability zones. And in that private subnet, they'll be doing auto scaling group, security group policies as well. We would be attaching that private subnet with a Bastion host for the load balancer. And we would also create the load balancer. First, go to your console and search for VPC. click VPCs, create VPC, click on VPC and more, and I'll name the project as CAF Demo Project. Scroll down, let's keep the same IPv4 CIDR block. Let's have like 2 availability zones and 2 public and 2 private subnets, 1 per availability zone of NAT gateways. Let's select none for VPC endpoints and then click on create VPC. Now you can see that VPC is creating. Let's wait for a few seconds. Now the VPC has been created. Now we have to create the auto scaling group. Go to the EC2, scroll down and find the auto scaling group and click that. Click on create auto scaling group. I'll name it same as CAF Demo Project. Click on create launch template to create a launch template to add on auto scaling group. When you are on the launch template page, name it same as CAF Demo Project. You can give whatever name you want and you can also give the description. I'll give it deployment in AWS private subnet. On the application images, select on recently launched. Select the instance type. I'll select the free tier T2 micro. You can also select that if you're on the free tier. Click on keep a login. I'll select the CAF DevOps demo keep a login of mine. Click on create security group. I'll name it same as CAF demo project. Description would be allow SSH access. Now select the VPC which you have created. I will select the VPC that was CAF demo project which I just created. In the inbound security groups, add the port ranges that you want to allow in this EC2 instance. I will be allowing the TCP port 8000, also SSH port access. Also make sure to add port 80 as well with the same method as I have added for others. So mention port 8000 with custom TCP. In the source, select 0.0.0/0, that would be internet traffic. In the source type, select anywhere. Now also create SSH security group rule to allow SSH traffic. And also create the same for port 80. Custom TCP protocol would be TCP port range 80. Now it's successfully created. Now add that launch template in the auto scaling group. Click Next. Select the VPC which we have created, KF demo project. As we are doing the scaling on the private subnet which we have created, so just select the private subnet. In this I can see private subnet AP South 1A and private 2 AP South 1B. I will select that. You can also select the private subnets. Click Next. In the desired capacity, you can mention minimum 2 and maximum 4 or 3. The desired capacity means like if there is a spike in the traffic due to festivals, there would be increase in the instances, and if there is less traffic and the traffic is decreased, so it would go to the minimum. Select no policy. Click Next. 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 Click on Create Auto Scaling Group. Now it has been created. Now you can see in the instances that we have two instances that are private subnets. Now the next step is to create a Bastion host. Click on Create New Instance or Launch an Instance. I'll name it Bastion host. Scroll down. I'll select Ubuntu. Instance type T2 micro free tier eligible. Select the key pair login. In the VPC network settings, select the VPC which we have created. In my case, it is KF demo project. Auto assign public IP enabled. Make sure that SSH security group policies is allowed. Now launch that instance. So now our Bastion host is created. Let's refresh. Now that our two private subnets and one Bastion host is created, let's understand the importance of Bastion host with respect to the private subnets. If you would observe, there would be no public IPv4 address to connect to for the private subnets. To connect to the private subnets securely, we would need a Bastion host. That Bastion host would be a public IP address that will help us connect to the private subnet so we can run our applications on private subnet. Now to connect to the Bastion host, first we have to copy the public IPv4 address. You can note that in your notepad so you can easily create the commands to connect to it. Now to let Bastion host act as a connection between the private subnet, we must need to copy the PEM file into the Bastion host. For this, we would need the command scp secure copy. What that does is it copies the PEM file into the Bastion host public IPv4, and that public IPv4 or that Bastion host, we can use that PEM file to connect to the private subnet. For this, The command is scp I space the path of the PEM file located in your device space again the path of the PEM file followed by Ubuntu at the public IPv4 address of the Bastion host :/home/Ubuntu. So this command would copy the PEM file located in our device into the Bastion host. Click yes. Now that file has been copied to that host. Now let's connect to that Bastion host to see if it is located or not. The command is ssh I PEM file name space Ubuntu at and the public IPv4 address of the Bastion host. Now we are connected to the Bastion host to the ls and we can see that we have the PEM file located in the Bastion host. So that PEM file would help us connect securely to the private subnet. Now to connect to the private subnet, we would need to do this command. ssh I name of the PEM file, Ubuntu at and the location of the private subnet which you want to connect to. In my case, we have two private subnets which we have created. We will connect to the only one private subnet and install the application and run the web server. Now I have copied and tried connecting it. It showed me some unprotected private key file. So to counterattack this error, we would need to give it permissions. For this, you must be using this command and then doing this. The command is chmod space 600 space tilde slash name of your PEM file, enter, and then do the same SSH command to connect to the private key. Now it will allow you to connect to it. Now we have successfully connected to the private subnet. Now let's do vim index.html. I have added this basic HTML code escape colon wq enter. Now python 3 space m http dot server and the port 8000. Now it's connected to the port 8000. Port 8000 is now active. For the next step, we have to create the load balancer. Go to your AWS console, search for EC2, scroll down and find load balancers. Click on load balancers. Select application load balancer. I'll name it again CAF demo project. Scroll down and select the VPC which we have created. CAF demo project. In the availability zones and subnet, select both of the subnets. On the availability zones and subnet, select AP South 1A, AP South 1B. In that, select the public subnet for each. You can select the security groups. Security groups in here would allow the rules of the security. So if a security group allows port 8000, if you have created that security group, you can add that. So in that case, I am adding KF demo project, default and launch wizard as well. You can select only one as well if you want to keep it clean. I have the policies and security group. I have security group policies that allows the traffic. So I have selected the KF demo project security group policy. Let it be port 80. Now we have to create a target group. Click on create target group. So it would open a new page of the target groups. I'll name it same as KF demo project. I'll mention the port which you have opened. In this case, it is 8000. Select the VPC as usual. I am selected KF demo project VPC. Click next and select the private subnets. Next, target group has been created. Select the target group which we have created. No need to change anything. Scroll down. Click create load balancer. Now wait until the load balancer is created. Our load balancer is created. Copy the DNS name and paste it in your browser like just I did. Now as I pasted that DNS name from the load balancer, you can see the web page which we have created, index.html on the private subnet. It mentions networking DevOps project 2, the project name which is by my channel. Now to sum it up this concept, first we have to create a VPC. Our aim was to deploy an application or a web server. We have utilized index.html to deploy it in a private subnet. The aim was to use a private subnet without a public IP address. We know that private subnet doesn't have public IP address and it is more secure than. So we created a Bastion host to connect to that private subnet. Also, we first created auto scaling group. What the auto scaling group does is it scales up the application when the traffic is high and scales down when the traffic is low. So we mentioned in the auto scaling group how much traffic, how much resources, how much capacity we need. Then we finally implemented application load balancer, creating target groups, security group policies as well. So that was the video for today. I hope the lessons and this message were insightful. Thanks so much for watching. Have a good day. Bye. And I hope the video was easy to understand from my side. Make sure you can like, share and subscribe and watch the previous videos if you haven't watched yet. Thanks so much for watching. Have a great day. Bye.